So right now I have it plugged in to the mains. There's a single screw there, and when I'm commanding it from here back and forth, you'll see it. So you can also hear it, and as you can see, it's doing some business. I don't want to actually melt, because it can melt it, no problem there. So what I've tested here is let me unplug it from the mains here. Precaution never killed anyone. Here is how I'm doing it, like on and off, very quickly. I'm also listening to the transformer. I can hear like a zoom when it's working. Here, what I've just tested here, I've tested this. Actually, let me check. Yeah, it is hot. Yeah, here, yeah, worm. Oh, that's definitely. Yeah, they should be cold, but they are hot. Probably the heat from this nail got dissipated into these two screws. But what I tested actually here, if these screws are optimal, if they are good, and I don't think so. They are still steel. They are made from steel, inoxidable steel, but they are resistive, too resistive and not that conductive as the copper is. So I will definitely have to buy a copper screw or a copper cylinder and attach it somehow to this rod, to this terminal here, to both of them, because the entire heat that is dissipating into this screw is quite high. Actually, it's like 50, almost like 100 degrees, only for a few seconds when this got hot, very hot, and I don't like it. It should remain cold, a little bit warm, probably from the heat of the nail. I'm not an expert, of course. These are my first impressions. Probably it should work like this, but I don't want it to work like this. If I'm putting too much heat here in the terminals, in these two conductors, I don't like it. But it can work if the resistance is or the diameter is smaller than these guys that I'm having here. To have it like this in this position, I actually made a little hole there with my drill, a 2mm drill there. And I made a little hole, and I very, very small hole, like this small, and this is actually getting into that. This nail is getting into that little hole. I cut its point, and I make it round at the end. And right now is just staying like that, is making some contact there. Actually, it appears is making better contact there than there, because that is the first part that is hitting up the first part that is hitting, that is getting red, and then is going down, which is I really wished to get in the center hot and then spread to the margins. This tells me that there is the better contact, and here is not that good contact, but it's good enough. It's okay. Yeah. Interesting experiment, and pretty good. I'm quite satisfied. And also why I tested, I made another test in the same time. The first one, I thought the first experiment that I did when I put the nail and it got hot in the kitchen, I was in the kitchen on the floor, and if something was getting in flames, at least it was not near the wood or anything like flammable or anything like that. I was very precautious. What I did it there is because the fuse that I have in my house is directly on the entrance door. It's an automatic fuse, but and it is in house. Actually, I was testing there in the kitchen. If the fuse was coming off, nothing else was affected. But here in my room, if the fuse is coming off, it will affect my computer. Everything is linked to a single wire, common wire here, pretty much from the I didn't want that in the very first try. But right now I just tested the theory of if I plug it in here in my room as an additional consumer, it's everything that I have in my room is still working fine, especially my computer, and it's good from this extension cord, this power extension, and that's another good thing. So okay, for now I want to actually put and measure the current that is passing through the primary, pretty much somewhere here. I believe I should do it to actually see how much is consuming when that is getting hot, and if I can do that safely, I can receive the wattage that is consumed, which is very important. I will do something a little bit dangerous. I will show you on video how I just got the measurement already. So I selected the alternative amperage, and this is 20 amps. I put it already. This is the common. It says here 20 amps maximum, maximum 20 amps, and keep it for 15 seconds also maximum. So if you are under 20 amps, you are okay. And I didn't know, and I kind of shit myself because doing this experiment, especially with my very old and trusty multimeter that I have here. So I set it to 20 amps here. As you can see, is more yellowish than this, which is also a little bit yellow, but it's supposed to be white. But this is for continuous amperage. It says there the straight line, but this alternating line is telling me this is the alternative amperage. And this is how I'm hooking it up. I disconnected. Oops. Nothing is plugged in right now. It's safe. Here is the plug. So I've disconnected this wire from there, and I basically inserted one probe there and another probe in continuation. It's looking like it's touching there, but it's actually staying on top of the isolator. I will have to reach with my hand here and not moving anything because they are kind of fragile there. I already did this experiment already. It's off right now, and when I'm pressing 3.6, 3.4 actually, that is doing that. 3.5, 3.6. Okay, I got 3.4 last time. Probably it's fluctuating. So this is the experiment. I did it very quickly because it's good to be quick, not to stay too much. Like I said, it's a bit dangerous stuff. And let me show you my findings on my computer. I searched before I searched for alternative wattage calculator, and I get this link here, and I get to this page, which is absolutely brilliant page, very good calculator. AC, single line, single phase. This 3 phases for motors, but single phase is 1 up, 1 down, 1 up, 1 down. Exactly the mains phase, pretty much, that you have in every single home. And in my case, I have 240 volts, alternative AC. And the amperage was 3.4 my last time that I did the calculation, the measurement. And I got this strange result, 775.2 watts. But it appears I didn't know at all about this power factor thing. Well, I know the power factor should be close to 1, and when it's close to 1, or even exactly 1, it's the perfect power factor, and it's good. It's something good if you have it like this. If it's not close to 1, or even exactly 1, or very low, like 0.5 or 0.3, that means something is like a resistor in your circuit that is eating power and is producing heat or a short, some kind of short, like exactly like what I did there in my experiment. So this is the result for alternative, which is a bit surprising. I didn't know this kind of calculations. And this is another page here. You see there, amps to watts. So this is actually a DC. Actually, you can change it here as well. But this is a DC current, and 3.4 amps times 240 volts is exactly what I did calculated with my knowledge that I had. So it's 816 watts or 0.8 kilowatts, almost 1 kilowatt, which is wow. it's quite something. It's quite something. It's like 100 watts light bulbs, like it was before. We were calculating wattage. A lot of people actually did it. And I learned it this way as well because it's very, very easy. The main light bulb in homes was 100 watts, and you calculated in how many light bulbs you have open in your house. And if you had 8 light bulbs in your house, you will get 800 watts, or 10, you had 1 kilowatt. So that's very interesting result what I get here. Actually, I can do it here as well. AC single line, and it's saying here power factor 1. In reality, you have some resistance in the wires, and it will never be 1. It will be less than 1, like 0.99, 0.95, whatever. Let's see, calculate. Come on, no, okay, then 0.95. Yeah, let's see, calculate. Oh, I see. So it was correct. If my power factor is 1, is ideal, it will give me this 816 watts as it is, as my original calculation. Okay, I get you. So if I'm inserting 0.95, it will go lower as it was before, a little bit less. Very interesting, very interesting. Depending on this is depending on the circuit that you plug into your power sockets, and how resistive it is. The more resistive it is, the less power factor you will have, and the less efficiency, pretty much. The rest of the efficiency will transform itself in heat, and is lost as heat, and is not good for whatever you are plugging it in. And your device is not efficient, pretty much, if it's too much less than 1. But if it's closer to 1, like this, 0.90 something, that's very efficient, pretty much. This is the efficiency calculation, or variable. This is a variable for efficiency, probably, most probably. It must be it. I'm also deducing stuff. I know something, but I definitely don't know everything. I know something, and I think I'm good enough for what I know. So this is a very, very interesting. Wow, 800 watts. But for very, very short burst of times. Actually, I keep it like 2 seconds in the kitchen, and also here in my room, kind of like 2 or 3, maybe 4 seconds, but until that nail got extremely hot. But usually what I have to do, the spot welding that I have to do with it, it will be a fraction of a second, I believe. It will not even reach 1 second. But that's the idea, and I hope it will work. We will see. Thank you very much until here, and I hope we will... I was very, very curious about the amperage that I will get from it, and it's now it's very interesting. All right, thank you very much. I hope you like it, and also leave a like. So this nail that I have here is called, the entire experiment that I'm having it using a nail is called the nail test. If the nail is getting hot, red hot, the entire machine, the entire ensemble, the entire device that I made here is optimal, is working. If something else is getting in flames, or in short, or making some weird stuff, then the experiment is failed, and that's what is telling me. This nail experiment is telling me this device is in proper order and is functioning absolutely fine, and is good to go. It's good to continue doing a lot of experimentation further on. I hope I will get my results that I really want to get from everything that I'm building here. So what I'm having here is 816 watts with a power factor of 1. efficiency of one, the maximum efficiency. If everything is at maximum efficiency, I bet my everything that this is not the real wattage. It's there should be some losses, I believe. I'm not sure actually, because this is the measured. It's not something that is written, so it might be 816 exactly like this. With or without efficiency, probably the amperage here was a bit more higher and some losses until 3.4 or 3.6 as I measured it last time on video. Actually, I measured it on video 3.6, but the first time I took it as 3.4. Okay, that's it. And glorious success I have. All right, here it is. It is unplugged. This is the cord. It is unplugged. If I'm putting this, nothing lights up. So right now I can safely put my fingers here. What I did, and this is a very good thing right now. What I did here, I'm trying to spot weld. I was trying to spot weld a single wire, pretty much, to a leg of a component, and this time I chose this dead MOSFET. I managed to fuck it up some time ago. It was staying there on the table, and I use it as a test guinea pig. And I put a single. This is a leg, most probably from a resistor that I cut it off some time ago. I have a bunch of them. Actually, I have quite some. You see, a lot of legs. This one I specifically choose it because it was magnetic, as you can see. And here it is, another one. And you see, if I'm putting, but it's too heavy. The magnetism is not that evident, but it was like this one, like this other one, exactly like this other one. And it was magnetic. My tweezers are slightly magnetic, and I pretty much put it there. One electrode on top here, and one the other electrode somewhere there on in the vicinity, just to create the path. And this is the button here. The idea is like this. Here is the idea. Right there. This is the button. It's connected to this electrode. This is a wire here connected to this electrode, and between those 2 points I'm putting whatever I want to put, and when I'm pressing the button is connecting this wire here to this end point there. So pretty much this is what it does. I know it's very weird probably for some, but it's practical. You don't have to use heavy expensive components. I did it with a couple of screws, and also copper wire. This is also copper wire, both of them. This is linked in continuation from here through here. This is an adjustment screw. If I'm loosening or tighten it, I'm making this head going much more harder or getting back slower, being easy to move it around. And this is having a gap here. I'm not sure if you can. It's kind of like this. You see, it's a gap. And when I'm pressing it, when I'm pushing it, let's see. You see, Puck is making that contact. He already made a burn mark there. And I don't like this directly on these electrodes that I'm having here, these terminals. I want to protect them, and I will have to sink harder, but I was extremely curious if it will work. It actually, I press it and keep it pressed for less than a second, like something like this, puck. And I was a bit scared because it's making sparks, big sparks, especially here on the contact, not there. But here when it's making the contact, is making quite a big spark, like this, big, like very white. And I was using my ruler here to press with it, to be protected a little bit, from the sparks. Who knows what shit can get on fire, and I don't want it. But this proves that this is actually welding, and it is welded quite good. I mean, it's solid. It's bending directly from the welding. You see, and it's not getting loose from them. But even if it was even loose, it was still a winner because I managed to do something, and it's a small step, but it's a good step. And yeah, next I want to try with LEDs, and if I can weld this leg, actually I'll cut it off from here, and if this wire I can spot weld it on the pins of the LED. Oh wow, that will be absolutely awesome. Absolutely awesome it will be. Wish me luck because it's very tiny. It's quite here is it is a little bit of distance indeed, but on the leg of the LED, on the pad of the LED, it will be extremely. They will be extremely close. These two pointers. I actually make them with is a pointer like that. Not exactly like that, but it's pretty much a pointer. There I managed to file it there and a little bit. And this is the button making contact and making a pretty big spark, but it's working. The idea is not actually this is not my idea. This is my friend's, my English friend idea. He was saying, well, actually this is my implementation what I'm having here, but I'm working on the my friend's idea. He was saying, he said to me that you don't need anything else than a short duration of time, as short as possible. And we were discussing about alternative, how to put here something that will power this device, the entire device, for a very short period of time, like a timer with a 555 or something, with an electromagnet or a solenoid that is creating the contacts from the 220 when it's pressed for a very short time, and is creating the impulse. This is powering up, and here in the end will create the spot welding. But there are a lot of problems. He actually gave me the page inrush current and spikes, pretty much extremely big spikes, and especially for transformers and motors. The page is absolutely phenomenal. It's extremely good. I had to read it. I know a lot of stuff, like general knowledge, but this page is full of other very interesting details. You have to read them, and you will learn a bit more than normal knowledge that you usually have. And it's covering a lot of details, very interesting details actually. And actually, that page confirmed my knowledge that I had previously, and also added a new little bit of little details. But it's a very good page, and we were kind of stuck at that principle, how to not make an inrush spike current from powering especially a transformer like this, and because it will reflect back into the power cables even to other devices, and it will affect, and it will spike like 100 times. And these are not my words, this is that guy words that he wrote it there. And those extremely high voltage spikes are very, very dangerous for everything, even for my transformer. It can burn it probably, or for other devices that are hooked on the same line, and I have a ton of stuff hooked up to this. And what I decided tonight when I built this contraption here, I decided to actually power it on. It's powered on 240 volts, and here is not making any kind of contact until I'm pressing this button. And when I'm pressing this button here, is actually making the contact that I already prepared. So I'm preparing there with everything unpowered, and then I'm plugging it, and then I'm pressing the on button here. I'm not letting it in on state, but I'm telling you I'm pressing it in on state, and I can hear the transformer buzzing. And then when I'm pressing this button, is already creating the contact, also creating a very big spark here. That is a bit so scary for me, but it's doing the job. That's and this is the entire solution that I have for the moment, and it is doing the job absolutely gorgeously. So I was counting on experimentation actually, to experiment until I will find the solution, and this might very much be the solution. I have to check, to experiment with the actual LEDs themselves, because they are the target for spot welding. For this device that I'm doing here, these long wires are absolutely not necessary for what I'm trying to do here. And probably in the future I will either take this out and put I have a remaining there. There I have a remaining of this cable, and I will put a little bit somewhere, I don't know how, probably like that long, or on top of this somewhere, right? I'm not sure yet, but definitely these are taking a ton of space that is stupid. A ton of stupid space. I don't need this ton of stupid space, especially for the purpose of this apparatus device that I'm making here. And I will have to make the test with the LED and see if the LEDs are still working after my spot welding. And they should work, and we will see after I will make the actual spot welding, and if they will work, then it's another life. It's literally another life, because that's a game changer. It will be a game changer, definitely. And yeah, I will have to be extremely careful how long I'm keeping my button here pressed. That's a very important thing, and it should be interesting to have a device that will do it automatically for me. But I will think in the future how I can make something with a solenoid, with something. I will think about it, but I don't think it's hard. I don't think it's hard, and I don't think it's impossible, even at this higher amperage and wattage that I'm getting through this terminals, these two electrodes. Yeah, whew. I hope you like it, and see you on the other side on the next experiment.